So this is a physical server. It has some amount of RAM. And we are installing, what OS we install here? ESXi operating system. On top of that, we create virtual machine. So here it will have virtual resources like VRAM, eCPU, virtual hard disk. VRAM, let's say 4 GB, eCPU 2, hard disk 50 GB. Okay, for a virtual machine. For this virtual machine, we assign RAM, CPU, and hard disk from here. From here, the quantity will be split and assigned to the virtual machine. So out of 100 GB RAM, now we have assigned 4 GB RAM to this machine. So it's a direct calculation. There is no logic, nothing. It's plain subtraction. We have 100 GB. We allocated 4 GB. We left with 96 GB RAM. If you create another virtual machine, let's say same capacity or whatever, different. We created another virtual machine. From this 96 GB RAM, so we have allocated 4 more. Okay. We left with 92 GB. Okay. So it's plain subtraction, the direct subtraction. 100 minus this quantity with respect to RAM. I'm talking about only with respect to RAM as of now. It's a direct subtraction. Okay. And with respect to hard disk, again same. It's a direct subtraction. Out of 1000, first machine we have allocated 50. We left with 950. Then from 950 we allocated another 50. So 900 GB. This is also direct subtraction. Hard disk and RAM will be directly subtracted from this amount. Okay, altogether makes this value. Okay. Now we'll discuss about CPU. So up to this RAM and hard disk, do you have any question? Okay, RAM and hard disk directly subtracted from the available amount on the ESXi host. Now we'll go and discuss about how the processor will be split. Okay, I'm saying Intel i5 processor, that means one processor. But how we can assign two virtual CPUs here, two virtual CPUs here? We need to understand some CPU terminology here. We'll see that. So to understand CPU split, we need to understand some basics of processor. If you see older days, the processor started with Pentium 1, Pentium 2, Pentium 3, up to Pentium 4, P4 processor. Intel P4. Okay. You have a motherboard. There is a small slot. Okay. If you see motherboard here, okay, this is a motherboard. Here, this is the slot, empty slot, where we insert a small CPU chip. This one, you see here, Intel i5, this one, i5, i7, whatever. This chip will be inserted here on this slot. Okay. This is called one slot. socket. One slot is called socket. So this computer has one socket where we will insert a small chip. The processor will take from here and will insert it here. Okay. This processor, once you insert it here, let's say it's already inserted. Just to identify, chip is inserted here. Now, if you are sending instructions to this computer, let's say I'm sending multiple instructions, first, second, third, fourth, fifth, like this multiple instructions I'm sending. What is from calculator, I'm typing like what is 10 plus 50. So multiple calculations at a time I'm trying to send here. Now, once it comes here, this Pentium processor, P4 processor, has only one core. That means it has one CPU or one processing algorithm. So when you send multiple instructions, only one instruction can execute here. It's one chip, one processor. Okay. So first one will execute, then second, third, fourth, they will be in queue. One by one, they will execute. Okay. And let's say it took 5 minutes to execute this is all work, whatever the work that we have sent to this computer. This is how computers were designed early days. Now, after Pentium 4, okay, the processing power is doubled. So they made processor same, one socket here, same like this one socket it is there. But the chip what we are going to insert here was initially called dual core. Dual core processor after Pentium processor. After P4 generation, the next CPU generation, they named it as dual core. That means it has one chip, same like this. It is one single chip, but it has capacity of two chips. Internally, the algorithms are doubled. One chip itself has a power of two CPUs, two processors. That means if you try to send same instructions here, first instruction will execute here. At the same time, second can also execute here in the second core. So logic, physically it is one single chip like this. Even Pentium 4 and a dual core processor looks like this only. But it has two CPU power. Internally, logically, the execution method feels like two processors. We see in a computer like a two processors. We'll see like virtually how it looks like. Okay, so that means two instructions at a time you can execute. First instruction, second one, third, fourth. So that means two instructions at a time they will execute on the two cores. It is one socket and two core processor. But physically it's a single chip. Here now we understood what is socket and core, right? So socket is this physical slot where we will insert, and core is this processing power inside a chip. Okay, inside that processor, it has double the capacity. Initially, when the dual core was introduced, it was not working that properly. The logic was executed, main logic what they were thought it was executed. There were some errors, and initially they made it as again after dual core they made it as core 2 duo, if someone remember. Okay. Core 2 duo processor, the same dual core only, but with improved algorithms. Whatever the errors they were facing, now they are clear. Okay, so same like two processor. Clear up to what we discussed now? Socket and core. Any question?
Clear.
Amit, any question?
No, sir. I got the answer.
Thanks. Okay, core 2 Duo, and later i3 processor came that we are even we see nowadays. One slot, which is one socket, and that processor. Now, how many cores? How many cores we have? 4 cores in IP processor. Okay. Now, 4 instructions you can execute at a time parallelly on this machine. So here, this, if you see 5 minutes, you can execute the same work. You can execute in 2.5 minutes, half of the time. Okay. Here you can execute the same work in 1.25 minutes. Still reduce the same work. If you execute on first computer with one socket and one core, it will take 5 minutes. If you execute it on one socket and dual core, it will take 2.5. On 4 cores, 1.25. So now your work is executing very faster. Right? But it's physically one single chip. Physically, it's a single chip. Amit, be on mute. If needed, you can unmute. One socket and 4 cores. So our execution speed is increased. Okay. Clear? So with the help of cores and sockets, the processing power is increased. So our work will be executed faster. Okay. Clear? Now. So this is with respect to personal computers. All personal computers, desktop and laptops, comes with one socket only. But cores can be 4, 8 also is there. i5 comes with 8 cores. Okay. 8 cores also is available. How to check? Physically, if you want to check physical processor, you need to open the motherboard and see. You need to shut down your laptop or desktop, open the hardware and see. If you open the hardware, motherboard looks like this. In our lab we kept somewhere. So it looks like this. And process chip looks like this. Top end and bottom end. Okay. Fine. No. If you want to see from computer side, how to know like whether there are how many logical processors. This course I'm referring to logical processors. Because it's not physical, right? Only splitted inside the algorithms. Virtually, there are 4 CPUs now. Here in this case, 8 CPUs. Okay. Clear? So how to verify? From here in your laptop also you can verify. Go to Task Manager, open it. Yes. Command to verify your computer configuration is open command prompt. Okay. From the command prompt, type system info. You get all your hardware component specifications. Okay. From here, all this your configuration. Okay. Now about how to check how many logical processors I have. If I open my laptop physically, it will be one slot here and one chip like this. But from task manager, go to performance, open resource manager. Here you can see CPU here 0 to 7. It is showing CPU 0, CPU 1, 2, 3, 4 until 7. CPU 0 to GPU 7. So total 8 CPUs. It's showing me, this task manager is showing me my computer has 8 CPUs. But if I open physically, it will be one processor. These are called logical processors, 8 logical processors. Thus, I'm referring to the cores. Clear? The same thing you can see here as well. Logical processors. One socket, 4 cores, and 8 processor. Why it is showing 8? 1 into 4, it should be 4 only, right? Why it is showing 8? We'll see that later. Okay. Fine, one socket and 4 cores. You understood, right? Now total number of cores in this computer, 1 into 4. In this case, 1 into 8. Now I've split it into 8. 1 into 8. Total 8 logical processors I have in my computer, in this computer. Clear? Socket,
Yes, sir.
cores. Cores are nothing but logical processors. Do not confuse between core and logic. When I say logical processor, sometimes core, sometimes core is equal to logical processor. Fine. Then this is about personal computers. If you see physical server computers, right? Server computers comes with 2 sockets minimum. One socket, physical servers also there, but nowadays one socket nobody will use. Minimum 2 sockets will be there. That means it's a CPU 1, it's a CPU 2. 2 sockets. If you want to check, just casually, server motherboard. You can see in our lab, you can open that board, the top if you want, you can verify it. Okay, right. Here you can see to very advanced, it has 4 sockets. Let me see the clear image. You can see 2 sockets here. Okay, this is one single server motherboard. It has 2 sockets. That means we can insert 2 chips at a time. Each one will come with again multiple sockets. Sorry, multiple cores. It comes with 2 cores, 4, 8, 12, and 16 is maximum. So this combination is available. Multiples of 4. 2, 4, 8, 12, 16. This combination we can purchase whenever you want to purchase. Okay. Again, if it has dual core, that means how many sockets and how many cores now? So you keep telling me sockets, 2 cores, 2 into 2, total 4. I'll mark it as 2, then finally total cores. Okay, 2 into 2, total 4. Now, how many sockets? How many cores? This one, 2 sockets. Each one has 4 cores. Total 8 cores. 8 logical processors we get. Clear?
Yes, sir.
Fine. Okay. Now, and in the physical motherboard, okay, there is there is a feature called hyper threading. There is a feature called hyper threading. If you enable it, number of cores, it will double the number of cores. When you enable feature called hyper threading, it will double the number of cores. That means this 4 core will become 8 here, this 8 core will become 16. It will still logically split like this. Same 4 core processor, it shows as 8 cores once you enable a feature called hyper threading. Clear? That we can enable on the hardware. Okay, so BIOS, okay, computer BIOS, we can enable. We can log into our ESXi host and check that also. How many ports it has, how many sockets it has. It has one socket, server computer with one socket and 6 cores. It's supposed to be 12 logical processors. Sorry, 6 logical processors, but it is showing 12 because of hyperthreading is enabled. If I disable this feature, it will show logical processors as 6 only, 1 into 6. As it is enabled, it's showing 12. Understood?
Yes, sir.
Yeah. Thanks. Now, again, the complexity will increase now. Okay. As of now, we understood cores and sockets, right? Now, with respect to ESXi, we'll see what will happen. Once you install an ESXi operating system, from single core or single logical processor, it can produce 32 virtual CPUs. Understood? Once you install an ESXi operating system here, single socket and single core, you can even install. It need minimum 2 cores. Okay, single socket, single core, you can't even install ESXi. It should be dual core. Minimum dual core should be there. Nowadays, even latest version, even it is not enough. It should be 4 core. Earlier, 5.5 it was working on dual core. Now minimum 4 CPUs. Yesterday we discussed, right? Minimum requirements for ESXi installation: 4 GB RAM, 4 CPUs. So minimum 4 sockets should be there. Sorry, minimum 4 CPU logical processor or cores. Okay. Once you install an ESXi host, it will produce 32 virtual CPUs from single core. That means on this computer, it has total 4 cores, right? Into 32. That many number of virtual CPUs we can produce. 128. 128 virtual CPUs will be produced from this machine, 4 core machine. Okay, and these virtual CPUs we will assign it to the virtual machines. Here, this count, this count. Here, and nobody will go to this level. Okay, even many people with real-time experience, even not even aware of this concept also, because every day they'll be working on VM creation, regular work only. So if someone is reading in depth about the subject, they will understand. Clear? So even during some interviews, they will ask how many virtual CPUs we can produce from a single core. But no one asked as of now, given thousands of interviews. No one asked. But if you see in the documentation, it will be there. Every version to version, this number will change. But nowadays, from 6.0 onwards, it's the same number, 32. Earlier, initially it was 10 vCPUs. Later, it became 25 virtual CPUs from single core. Later, 32. It's constant now. Where to check this? How to believe this number? Okay. So in the VMware documentation, just type something called vSphere maximums 7.0. Every version. So I want to check for 7.0. Click on it. This is official VMware website, right? kb.vmware.com is official website where it gives the information about their product. So we can blindly trust this one because this is the company who developed that ESXi. They gives better information than anyone else, right? We can blindly trust about this number. Okay, so here someone was asking how many VMs we can create per host. 1024. Okay, so virtual. I'll just here virtual CPUs per core 32. Okay, this is VMware official website. It depends on the number of workloads, lot of metrics. You just look for performance best practices. So this is maximum product supported, but nobody will use maximum. People will consider 1 is to 4 is a good number. Okay, without any performance issues. Recently in my company, we have achieved like 1 is to 7. Lot of people are complaining about performance issues. That means one core we are producing 7 virtual CPUs. Here itself, people are complaining performance issues with respect to CPU. Okay, if I consider 32, what will happen? That company will close within a day because of every customer will go away from that client. They can't even run their workloads. So that's what they are saying. Like you need to consider your performance best practices. Okay? So while you are considering number of cores, but product allows up to here. Fine. Okay. So like this. Now a small practice we'll try to do. We have a physical host. Okay. I'll give numbers. First one I will explain. Listen carefully, and we will not work on real-time, day-to-day basis, but it just helps you to understand the subject better. Okay. So we have an ESXi host here. Now I will not write a physical server anymore. When I write ESXi, you understand that's a physical server. Okay. So here I have 100 GB RAM. Okay. So one socket and 2 core processor, 1000 GB hard disk. Hard disk I will ignore. 100 GB RAM and 2 core processor. Overall 2 cores. One socket and 2 cores, right? 2 cores. I need to create virtual machines here. It's fine. It will allow us to create. Every virtual machine should get 4 GB RAM, 2 vCPUs, 4 GB virtual RAM and 2 CPUs. It should get. How many total number of VMs I can build with this specification? Okay. Anyone can try? If anyone wants to try and let me know answer, I'll explain again. Later you can answer. How many? 32 VMs. Okay. With this specification. Fine. No problem. Even if it is wrong answer, that's fine. You are trying at least. So better than Others who is sitting idle. Madhukar Trust says 25 VMs. Anyone else? Any number. Just don't think, just give us some number, that's fine. 16, 25, 25, 32, 25. Fine, that's fine. I'll give you answer for the explanation for one example, then you let me know again for next example. Okay. So every virtual machine should get 4 GB RAM. First, we will consider with respect to RAM. With respect to RAM, 100 by 4, right? With respect to RAM, sorry, 4 by 100. Sorry, 25 VMs. 25 VMs we can build. With respect to CPU, 2 cores. Each core will produce 32 virtual CPUs. So that means 64 virtual CPUs we have. Total we have 64 vCPUs. You agree with this? Okay. Now, every machine should get 2 CPUs. That means with respect to CPU, 64 by 2. Okay, 32 VMs. Now, with respect to RAM, it's a different number. With respect to CPU, it's a different number. No issues. When we are creating a virtual machine, we cannot split RAM separately, CPU separately, right? We cannot separate it. Every virtual machine should have RAM and CPU. So it will be minimum of this number. If you say 32 VMs, we don't have enough memory. If you take with respect to RAM 25 VMs, CPU we have enough CPU. Extra CPUs, leave it, no problem. Possible number is minimum of 2. 25. So 25 is the correct answer here. Okay. You need to consider with respect to RAM, with respect to CPU, and minimum of 2. Clear? So next example you tried. That's fine. Like I didn't give you explanation, but you still tried. Okay. Now you tell me. I'll change the numbers. No need to worry. Even if you don't understand, that's fine. Like no one will ask in real time. 128 GB RAM, 2 sockets, and each one has 4 core. Now you calculate yourself and tell me I need a virtual machine with a 4 GB each and 4 vCPU each. Number 32. 32. Okay, we'll see that. With respect to RAM, 128 by 4. 32. Okay. And with respect to CPU, 8 into 32. 240, 256, right? 256. And by 4. 64. 64. With respect to CPU, we get 64 VMs. With respect to RAM, 32 VMs. So minimum of 2, 32. And you don't need to worry now. You don't need to never need to manually calculate this number. The capacity management tools are available, and even nobody will go to that level. Just for your knowledge and explaining how the processor will be split. Amit, is it clear?
Yes, sir. Clear.
Any questions? Now we understood how the RAM will be splitted, CPU and hard disk will be splitted from the ESXi to the virtual machines. Okay. And small assignment for you. You need to check what is SMP, symmetric multi processing, and NUMA, non-uniform memory access. Just try to find what does these two mean. Okay. During next class, I'll just ask about these two things. SMP related to processor split, NUMA related to memory split. Okay, just read about that. What it does, how it is. The technology behind splitting the processors like this virtual CPUs is SMP, and memory splitting is NUMA, non-uniform memory access. Okay. Any question from anyone? On the team viewer, how to connect back again, I'll show you. So in your laptop, you have internet, open team viewer application. Once you install team viewer application, open it. So it will be like this. Here you need to enter the ID and password, and this I will get you when you ping our. So it's the same number, the same computer I'm getting. This is the same ID, and when I connect, internet. No, my lab machine is not connected with internet. Let me check. You don't need to send this your ID. If you send this ID and this password, someone can access your laptop. Okay. So here you need to enter our lab machine ID and its password. No, internet is not working. Okay. No, still not. No, it has some issue. Three? Same. 122. Same. Okay, sorry. 35172635. So once you enter that ID, if that machine is connected to internet, it will ask for password 2AX1XA56. So here you will get access to our lab machine. So from here, open web browser, enter the vCenter IP 0.200 in our lab. Use vSphere client. Okay. Administrator at vSphere.local, Windows 123 at the rate wcaps. I'll share this username and password. Okay. You will be connected to the vCenter like this. However, I connect from laptop, you can connect. So from here, you can create virtual machines. Right click, new virtual machine. The ISO image is located in the data store one. If you browse it, you can see all the ISOs here, 2012 and 2016 without any need. So check today's video if you want to connect it to TeamViewer and how to log in. And the username and password, I'll just. So if you want to connect to vCenter, 192.168.0.200, username for vCenter, administrator at vSphere.local. We'll see where it comes from. 5@vSphere.local. Password W caps letter Windows 123 at the rate. If you want to connect to ESXi machine, 192.168.0.240, username root, password same password Windows 123 at the rate. If anywhere, not these two machines, any other machine, if you need password in our lab, the password will be Windows 123 at the rate or root 123 at the rate. Try these two passwords. Okay, it will work. These are lab default passwords. So you can try that from TeamViewer. I'll just ping you contact number whom to contact for the TeamViewer ID. If someone is already like there are 3 to 4 working machines, parallelly 3 to 4 guys can work.